Okay, let's look at a transformation of a logarithmic function. Let's assume that this graph started, let's call it g of x. G of x is log base 3 of x. Okay, so we have some transformations down here that we don't see up top. Okay, but let's graph g of x just for sake of comparison. So we have our intercept at 1 comma 0. We have our vertical asymptote. I can finally use the yellow marker here and trace over the y-axis because that's our asymptote for a logarithmic function. When we have, let's start here and just draw something that resembles logarithmic growth. Okay, so something like this. All right, and again, it's a slow growth this way, and it is asymptotic behavior as it approaches 0 from the right. Just keep in mind that that is an asymptote because I can't plug a 0 in here, right? There's no power that I can raise 3 to get 0. All right, now let's talk about the transformations. Logarithms are a bit easier to handle than exponential transformations because there is a quote inside to a logarithm. Okay, the inside is literally whatever follows the base of that log. So in this case, it's just an x, right? And it started as just an x. So we see no inside transformations. Okay, so you're going to see parentheses if there are inside or aka horizontal transformations for this function, but we don't have that. Okay, we do have two elements here that weren't in the original function. That's the 2 and the negative. And you're going to see your transformed logarithmic functions look like this. But let's be clear about what that means, right? So this is really the same as 2 plus the negative log base 3 of x. All right. And because addition is commutative, I can rewrite this as negative log base 3 of x plus 2. Okay. So we like to see that floating constant in the back, like with our linear functions like mx plus b. We don't typically see that with these functions, with these logarithmic functions. If there's a floating constant, a lot of times it's put in front. And the reason for that is because if you put something like this, okay, that gets kind of confusing in terms of what's inside the log and what's not. So a lot of people will assume that if there's a plus 2 right here, that it's grouped with the x. Okay, but this is still, we would still consider that a floating constant. Anything that's quote unquote inside the logarithm is going to be surrounded by parentheses. So in other words, the logarithmic function log base 3 of x plus 2 is very different from log base 3 of x plus 2. So if we don't see those parentheses, then the transformations are not inside the function. That's why we write that constant in front, even if this is a negative. Okay, but what is it? It's a floating constant, and floating constants are vertical shifts, right? And then negatives that are outside the logarithm, not inside the parentheses, this is a reflection over the x-axis. Okay, so the first thing that we're going to do to show that reflection over the x-axis, because we have to do our multiplication before we do our addition for these transformations, is we're just going to take this top, let's call it the top half, all right, and separate it from the intercept point. So let's move this down here, and then we'll move this other part, have its reflection up like so. Okay, so that accounts for the reflection of the graph. Now, in terms of the vertical shift, okay, the way that I've always done this, and sorry, I should mention this as well. The asymptote, the yellow line here, also flips. But if you flip, this asymptote where this side flips down to here and this side flips up to here, it's still the same line, right? So we are also reflecting over the x-axis for this asymptote, but it's the same asymptote at this point. Okay, now when it comes to moving the intercept or the rest of the graph, I focus on just the intercept point. Okay, let's see if I can get it. Here we go. So this intercept point is moving up. Oops. There we go. 2 units. So we get to here. Okay, so we went from an intercept point that was here up 2 units to this point here. So now we have this point as being, instead of 1 comma 0, it's 1 comma 2. And the vertical asymptote for this graph is also x equals 0. Because what happens when you take a vertical line, and see if I can grab it here. What happens when you take a vertical line and you shift it straight up? If you take a vertical line and you shift it straight up, it's still in the same place. So shifting a vertical asymptote vertically doesn't change it. Flipping it doesn't change it. The only thing that'll change this asymptote, okay, is if we have a oh gosh, I keep grabbing the wrong thing, is if we have a horizontal shift of this graph, which we don't have in this case, okay?